high. And we could also develop along with it, are doing right now. And which code that we have for now compatible with volume manufacturing. If we still go for the EW Association reports, we can clearly see that the cost per kilowatts dropped around 5 kilowatts. So this is a really sweet point that we can try to reach in future designs in order to lower the cost of the energy, like for rural zones. If we look at the power flow of a wind turbine, I would like to focus a bit on how it works. Like on the left side of the picture in green, we have the mechanical power. That is on the left side of the picture in green, we have the mechanical power. That is generating an AC power that will go in the electric parts shown in yellow in the picture. We also have the chemical power that is used as storage. Well, an important thing to keep in mind is that if we want to try to reach the 5 kilowatt scale, we will have to increase the control over the system. And therefore, we will increase the complexity as well. If we try to break down the complexity level of the system, like for different small wind turbines, we will see that, like for from the pico and the micro scale, we will have only one point of control, 1 degree of control. And it's always on the chemical power, because, well, if you don't protect your battery, then it explodes, it blows up because of overcharging or over-discharge. But when you want to go for higher power ratings, you will have to necessarily go for higher level of control over your system somehow, because you won't be able to master the mechanical power or the electrical power. So you will need to add somehow a new degree of control on your system. This is why wind empowerment developed different technologies to try to cope with these issues. We developed a really simple analog charge controller to avoid your battery to blow up and to give a replacement to proprietary designs that are often really expensive. We are also developing a power converter suitable for microgrid application that was presented in the last panel. And I'm personally working in control algorithm aiming at controlling the electric power flow. By controlling the power flow, as shown before, with the degree of freedom, we can get partial control over the global wind turbine, and therefore we could think of bigger turbines based on the UP design. What could be interesting for future development as a roadmap would be to develop a pay-as-you-go module for the Pigot technology. And therefore, we could think of different business cases where we could pay for trained maintenance from the electricity. Think of lowering the tool list required to build small wind turbines, because for now the technique still use a lot of different tools that are not really the easiest way to make a manufacture out of small wind. So clearly the vision is to try to accelerate the development by bonding big links through like the intelligentsia of different countries, because obviously wind is really difficult compared to solar. Even though we've seen it has really big advantage for development, like local development, it must go like at some point through university to share the knowledge with local persons and citizens. Also, well, if we want to see more installation on the field, well, we will have to provide at some point local entrepreneurs and enthusiasts with a new recipe to get faster in the business, because for now it's still tricky. Like, you don't have a resource that will give you the recipe to start a business. You will still have to go through a lot of research for different things in your home country, so it's still difficult to jump in the business. But